Hi, Sheila. This is Wendy Nixon. Thank you for your post. Was very well written on question 12 about platykurtic and leptokurtic kurtosis. I'm very thankful that you responded to this question. I did as well. Um, the definitions that you described in your post are very thoroughly explained and easy to understand. You know, you really made it understandable. So it seems like, you probably have a teaching gift. And I think I remember us talking on other posts that you work with children like I do. That just becomes part of your makeup when, when you work with children and teach children. Um, so I thought of a simple mnemonic to help remember the definition of platykurtic. Um, with all these words, I try to make those word associations. So I thought of a platypus, which is, of course, an animal with a flat tail, and associated that with platykurtic being, kind of a flattened curve. So I did look up on dictionary.com platy meaning and definition, and in Latin platy means flat and broad. So I was thinking that probably was true, but I like to look stuff up, of course, to confirm. So the takeaway that I received from studying platykurtic and leptokurtic is that the distribution of the data is no longer within the normal curve or the bell curve, being that it's more or less varied and either flattened or peaked. So from Salkind and Fry, our textbook 2020, Statistics for People Who Think They Hate Statistics, discussed, of course, not only the definitions of these terms, but that when you lose the normal or bell curve, you lose the predictability that you can apply to your data. That, for example, approximately 1/3 of the data in the normal curve is plus or minus one standard deviation of the center midpoint, which is the mean, median, and mode that have an equal value. So that was a good takeaway for me. Also, I liked in your post that you ventured out to give examples, but I did notice on page 143 of our Salkind and Fry textbook 2020 talks about that IQ and height are typically fall within the normal curve. You might want to just check that out. Page 143. I think it was very brave of you to give examples. Again, that was something that I didn't venture to try. I'm glad to get down the basics of the information and kind of hold on to that for now. So thank you for making that effort. I did find an article that talked about, the article was McNeese, 2016, Are skewness and kurtosis useful for statistics? So in this article, McNeese talks about kurtosis can be calculated. Degrees of kurtosis can be calculated. Kurtosis being, of course, the distribution of the data is not clustered around the center. So I suppose, if one was really doing a lot of math and statistical calculations, that may be useful, I guess, at some point, but certainly I think not for our class, and something that I am not going to, of course, ever try to calculate. But anyway, just thought that was interesting that, it is a possibility. And also, of course, the article talked about how if you have more data points, the curve and the visual representation can be more accurate, and that kurtosis is helpful in getting the visual of the shape of the curve. Well, thank you so much, Sheila. It's great to be in class with you. Take care. Bye.